We are getting close to the end of this course, and now let's go through some advanced aspects of Kafka. One of the GDPR-friendly features, tombstones. You can publish some messages and store them in Kafka, but how to hard delete them? This is one more use case besides log compaction where messages keys are useful. As to delete a message, you need to send a null payload with a specific message key. And this needs to be a real null, not a null string. Sometimes you might need to publish some huge messages in Kafka, and by huge we could consider anything greater than, let's say, 1 megabyte. Before doing that, it would be worth considering some alternatives. Maybe you could upload something to Amazon S3 and publish a link instead. But if you really have to do this, you will need to adjust 4 things. One on consumer side, fetch message max bytes. It's the largest size of a message that can be fetched by a consumer. On the broker side, replica fetch max bytes, required for proper replication. Without changing it, you might get some silent failures, as basically events will not be replicated and you will not know anything about the issue, which is pretty nasty. Again on broker, message max bytes, which is the maximum size of the message that you can publish to Kafka. And again on the broker, max message bytes, so kind of like similar to the previous one, which is the largest size of the message that is allowed to be appended to the topic on the specific partition. Some performance related question. How many partitions should you really have? So obviously the more partitions, the more throughput you can achieve. But you shouldn't add more partitions that you might need. And for that you need to think about the expectations for consuming messages. What kind of throughput do you expect? For example, if processing a message takes 10 milliseconds and you want to process 1000 messages per second, you might just need 10 partitions and more will not be needed. The more partitions you have, the higher potential unavailability if some broker is down, and also the more partitions, the higher latency and increased replication time. That doesn't mean that with hundreds of partitions and broker going down it will cause 10 minutes of unavailability. It's not really that drastic, but it's important to do the math and not add as many partitions as Kafka can handle, because it will cause more issues than it will bring benefits. So the ideal number is the one that comes from the result of the actual calculation behind it. In the monitoring part, I mentioned that it's important to make sure that there is always only a single controller. What is this controller then? A controller is just a standard broker that gets elected as such, that has some extra responsibilities, like electing partition leaders, for example. It's the first broker that registers itself as a controller in the cluster when there is none yet. Replication is definitely something critical in a production setup, as most likely you will have more than one broker. Ideally you would start with 3, but 5 is even better. Replication is necessary to have a reasonable availability and durability. The replication factor, which determines on how many brokers the partition will exist, can be configured via replication factor config option. It's worth keeping in mind that a replication factor of n, so for example 3, allows to lose n-1, so here it will be 2 brokers and the cluster will still be operational. So we can have partitions on, for example, 3 brokers. In such case, one of them will be a leader replica and 2 of them will be the followers. Each partition has a single leader and all requests go through that leader. And the purpose of follower replicas is not necessarily to be involved in this request, but to make sure they are up to date with the leader and that they are able to take over if the current leader goes down and become a new leader replica in such case. There's one important term that is worth understanding. It's in-sync replica. And in-sync replicas are the ones that are up to date basically, but what does it really mean? It's a property that can be configured via replica lag time max milliseconds, and that way you can establish a threshold when a replica can be considered up to date or no longer up to date. To ensure better consistency guarantees, you might choose to require messages to be committed to more than one replica. You can configure it via min in sync replica setting and determine on how many brokers the partition need to be in sync. For 3 brokers, it's reasonable to set it to 2, and that way even if one broker will go down, Kafka cluster will still be operational. But if you lose 2 brokers, then it will no longer be possible to publish messages to the affected partitions. If we are on in-sync replicas, there is one more concept that would be worth understanding, which is the leader election, which can be clean and unclean. With clean election, which is a standard process, an in-sync replica is chosen as a new leader. But what if no in-sync replicas exist? This can happen, for example, if brokers go down one by one. It's a difficult choice because the consequence of allowing unclean leader election is potentially losing some message, or pretty guaranteed that you will lose some messages. On the other hand, the alternative is Kafka no longer being available at all. So you need to choose between consistency and availability, so it really depends on your applications and whether you can afford to lose messages or not for the sake of availability. This setting can be configured via unclean leader election enable, so either true or false. In distributed systems, a split brain is something that happens every now and then. So imagine that one controller goes down and it doesn't necessarily need to experience hardware failure. It's just from the perspective of the system. It just gets unavailable for whatever reason. Maybe there is some network partition, maybe there is stop the world garbage collection pause. So if it takes long enough time, a new controller will be elected. However, the old controller will still think that it's still a controller and could try to act like one. And this conflict is called a split brain. Kafka prevents that stuff from happening by using an epoch number, which is a monotonically increasing number for the controller. So basically, the controller with the highest epoch number wins, and that's how the true leader can be recognized. Zookeeper is not the part of, let's call it, Kafka core. It's a separate component, but it's heavily used by Kafka. So what is it? Zookeeper is a service for maintaining shared configuration. In case of Kafka, it's used, for example, for electing a controller or to keep info about membership within the cluster, so basically which brokers are part of that cluster. But in near future, it's actually expected to be removed from Kafka core. One more thing that would be worth speaking about is producer's reliability, which basically means making sure that the messages will be published and will be stored in Kafka. With consumers, it's way easier as we can just go with at least once delivery, and if we don't do any weird stuff with committing offsets, then we should pretty much be fine. Unless the consumer cannot consume the messages for some reason because, for example, raise application raises an error and it just stops. With producers, it's more tricky, but it's still doable if you know what you're doing. One thing that we can do on the Kafka level is configuring the number of required acknowledgements. It could be either 0, which means you don't care about losing messages in such case because it might happen. 1, where the leader has to acknowledge the message being published, and you can also require all in-sync replicas for the egg, which is a good idea if the performance is still satisfactory with that setting. But there's one more thing that you need to think about when publishing a message and getting an error, because the cluster might be down for whatever reason, even for a legit one, like maintenance, for example. In this case, you need to retry somehow later. So probably you will need to catch these exceptions, store the messages that were not published somewhere, and try to publish them later. This is doable, example with Sidekick, and you can store such messages in a dedicated queue and process the jobs when Kafka is back. And that will be it for the advanced Kafka part. It's definitely not everything about Kafka itself, but it should already help you understand some of its important aspects. And see you in the last part, which will be dedicated to more advanced Kafka usage.